When a host transmits a TCP packet to its peer, it must wait a period of time for an acknowledgement. If the reply does not come within the expected period, the packet is assumed to have been lost and the data is retransmitted. How long TCP should wait before retransmit? This simple question is difficult to answer. Over an Ethernet, no more than a few microseconds should be needed for a reply. If the traffic must flow over the internet, a second or two might be reasonable. If we're talking to an instrument package on a satellite, hurtling toward Mars, minutes might be required before a reply. As you can see, there is no one answer to the question. TCP implementations attempt to predict future round-trip times by sampling the behavior of packets sent over a connection and averaging those samples into a smoothed round-trip time estimation. When a packet is sent over a TCP connection, the sender times how long it takes for it to be eked. Let's see how TCP calculated the smoothed round-trip time from these two samples. The basic formula for calculated smoothed round-trip time is alpha multiplied by the current smoothed round-trip time plus 1 minus alpha multiplied by the current RTT sample, where alpha is a constant between 0 and 1 that controls how rapidly the smoothed round-trip time adapts to changes. It is often equal to 0.9. Let's use our example. The first RTT sample was 1.3 seconds. According to the RFC, at the first measurement, the smoothed round-trip time should be equal to RTT sample. Putting everything into the formula, we get 1.24. Now TCP can compute the retransmission timeout by using the following formula, where upper bound, for example, is equal 1 minute. The lower bound is equal to 1 second, and beta is a delay variance, usually 1.3 to 2 seconds. TCP will update its timeout timer to 1.612.